Hey everybody, welcome to day 4 of quarantine for the coronavirus. Oh my gosh, I can't speak. um, yeah, so I've got the notes up from yesterday just to kind of mention a few things. We're going to talk about what we did yesterday. Yes, COVID-19, much more formal way to say coronavirus. Um, how's everybody doing? It looks like we've got some people in. We don't have everybody here. We need to get some more people joining in, hopefully in the next 5 minutes or so. What kind of, any questions from yesterday's lesson? Yeah, Cooper, I feel that. I feel that. Definitely tired. Definitely tired. Let's see. Yeah, stream's going good. 4% of Americans is a little high, Valen, sorry. 2% would be debatable, but that's just people who get that. Okay, so when should we have the reading done, Sadie? That's a really good question. As soon as you can would be my answer. We are kind of going to be talking about all the stuff that's in the reading, and so having that background for the reading is going to be really useful to participate in discussions. So I would for sure try to have it done. If you don't have it done yet, try to get it done by the end of the day so that for tomorrow you can know what's going on as we talk about colligative properties and some things we're going to talk about tomorrow. It's really dark outside. It's really gloomy. It's kind of like overcast. I just noticed that as I'm looking out my window. Yeah, Tyler, at the end of the stream, maybe my kids will come up and get restless and come say hey, but who knows? Okay, so the reading... Ellie's asking a question. So, reminder, the reading was Roman numerals 8, right? Well, actually, just Roman numeral 8. Roman numeral 8, pages 452, 465, and 471 to 479, and 482. Right? So, yeah. Okay, so just to recap on the reading that you guys should have done. Let's zoom in a little bit on that. So again, it's going to be that. Yeah, no, I'm not gonna do attendance or anything like that, Cooper. I'm just gonna make sure that everybody keeps up to date on things. Like if you haven't graded the Strength of Bonds worksheet, I'm probably going to reach out and call your home tomorrow sometime. So make sure you get the Strength of Bond sheet in and graded before then. And then I am going to put up a couple other assignments on Canvas as we're going. So I'm trying to take everything that would be doing physically in class on paper and trying to make it more digital so that it can be easily submitted and easily graded from home. No. It's fine for now. Izzy, just try to get it done by the end of the day today. If you don't have the Strength of Bonds graded by tomorrow, it's technically open until Sunday, but if you don't have it graded by tomorrow, I'm going to be making phone calls home because I want to make sure that everybody has been participating and everybody's been doing what they've been doing. And my easiest check on that is going to be to check who's turned in the Strength of Bonds and who hasn't. So the people that haven't turned it in, expect a phone call to your parents from me. So just make sure you get it done by the end of the day. Are we still having tests for 13 and 15? Yeah, we are. But it'll be like open note, and it'll be on Canvas. It's blurry. So make sure you crank up to 1080p on the gear setting on the stream, so that you can actually see. Yeah, it'll be open notes, Cooper. It'll be open notes, Cooper, because I I can't make it so it's not, because I don't trust you guys enough to be on your honor for that. So yeah. No, you're not gonna have to turn in your notes, Eliza. I never grade notes. I never do that stuff. My camera is terrible. It's just a Logitech. I mean, it is a 1080p HD camera, but it's not a great camera. So I'm glad that the quality is good. I just borrowed it from the principal. The test, well, it will be when we finish the notes. It'll be sometime next week, Jonathan. So don't worry about that. Okay, let's go ahead and recap yesterday's lesson, so we can pull that up. So remember, yesterday we were talking about how do things dissolve, and we ended off kind of getting towards acids, right? So we talked about particularly, how, so here, Xander, let me show you. So if you look on the stream, there's this little gear in the bottom. Click the gear, click quality, change it to 1080p 60. Okay, hopefully that helps. All right. Yeah, Ellie, try to get the strength bonds in by today. Good, Johnny. I'm glad you're stuck here with me. All right, so recap yesterday's lesson. So we ended off yesterday talking about how the way all things dissolved. We talked about how molecules, when they dissolve, they stay together. We talked about how when ionic compounds dissolve, they break into their ions. The new things we're really talking about now are acids. So reminder that we said that you can classify acids as either strong or weak. And there are 7 strong acids that you need to memorize: hydrochloric, hydrobromic, hydroiodic, chloric, perchloric, nitric, and sulfuric. So make sure that you get that list memorized. And then any other acid you consider to be weak, like hydrofluoric acid, carbonic acid, phosphoric acid, chlorous acid, nitrous acid. Yeah, flashcards is a great way to do it, Trinity. That would be a fantastic thing to do. Just 7 quick flashcards. Now, the reason why we care about the difference, the reason we care about the difference between strong acids and weak acids is that strong acids completely separate in solution. So contrary to what you might think, strong acids don't mean that they're more dangerous or more reactive. All that we're talking about when we talk about strong and weak is how they break apart. Technically, if you ask me, I'm more afraid of the weak acid HF than I am of the strong acid HCl. Because the weak acid HF can dissolve your bones, and really, really bad stuff can happen from that. Even though it's technically a weak acid, it still is going to be something that's dangerous. So when we say strong and weak, we're not talking about how dangerous they are. We're talking about how much they break apart into ions when you form aqueous solutions. So the strong acids totally break apart, right? And they form ions, whereas the weak acids stay together in aqueous solutions. So the water is still water. The only thing that kind of gets messed up with the water is that one of the waters turns into hydronium. Okay. Oh, Xander, did I miss your question? Yeah, so there's an assignment on Canvas that you can basically turn it in. So if you go to Canvas, oops, that's full screen. So if you look on Canvas, this is what you'll see, right? So click on the modules. If you go to the modules, we go to grading strength of bonds. Click grading strength of bonds. Here's the key. Download the key, look at the key, submit the assignment. All you do is just put your score, right? 40 out of 40. Oops. 40 out of 40, right? Or whatever it is, and submit. Okay. All right. So yeah. So when we say stronger, Lauren, we mean their ability to conduct electricity, which is what we're going to talk about today. So let's get into what I mean by strength and what I mean by their ability to conduct electricity. So that's kind of a good segue into the notes for today. So we say weak acids mostly stay together when dissolving. Right, that was the last thing we kind of jotted down. Okay, so new number, number 5. So number 5 is just kind of a mention so I can be thorough. That metals will mix with metals to form alloys, but they don't dissolve in water, which you guys know. So metals will mix with metals, but they don't dissolve in water. Yeah, Cooper, it's all about electrical conductivity when we say strong and weak. That's where we're going with it. Okay, so there are some metals that react with water. There's some cool YouTube videos I'm sure you've seen about putting sodium in water and potassium in water, and they react explosively with water. But when we say that they dissolve, metals as a metal does not dissolve. So an alloy, real quick, Ellie, an alloy is just a mixture of metals. So an alloy would be something like bronze, which is a mixture, or brass, or stainless steel. Those are all alloys. They're mixtures of metals that, depending on the ratio of the elements, gives you different properties. Yeah, Cooper, I beat you to it. Okay, so let's see. What we want to talk about next is we want to talk about number 6. Lauren, I'll get to your question real quick. They're not weak. They're non-dissolving. So, Caden, you should be able to open it either with Google Docs or with Microsoft Word if you have Word, or you can open it in Google Docs. Everybody has Google Docs. Okay, they aren't weak. They aren't strong. They're non-dissolvers. Okay, because they don't dissolve. All right, so let's talk number 6. Let's talk electrical conductivity. Okay, so I've got a quick picture to show you guys, right? So when we talk about electrical conductivity, we can talk about non-electrolytes, or non-conductors, weak electrolytes, weak conductors, and strong electrolytes, strong conductors. What they've got here in this little apparatus, which if we were in my classroom, I would have actually showed you guys. I have a similar setup in my room. But the idea is that if you hook up a power source, right, to a light bulb, and you have these two probes, okay, if the solution here conducts electricity, then the light bulb turns on. If the solution doesn't conduct electricity, then the light bulb, of course, is off. So if we have a really strong conductor that conducts the electrons through here very rapidly, then you get a very bright light. If you have a weak conductor, you have very dim lights. So yeah, when Gatorade comes out and they say, now we're the electrolytes, they're basically meaning that it has dissolved ions that can conduct electricity and all these things. Okay, so yeah, the same electrolytes that are in your sports drink or whatever they try to sell you. Basically, when they say that it's got electrolytes, they're really just saying it's got salt. But they're being fancy because they're trying to get you to buy it. And people are dumb. Okay, so when we have electrical conductivity, we've got the 3 things we're going to talk about. We're going to talk about non-conductors, and I'm going to leave a little space. Non-conductors, strong conductors, or electrolytes, either phrase works, and weak conductors. Oh, sorry. Let me put the screen back up. I'm getting there. I'm getting there. Chill out. You guys are so triggered so easily. Okay. So, non-conductors, strong conductors, and weak conductors. The whole chat right now. We can't see. We can't see. We can't see. Okay. So, anyways, non-conductors, strong conductors, weak conductors. All right, so okay, so when we talk about non-conductors, we've already talked a little bit about how certain substances conduct electricity. So this will be a little bit of recap, plus we're going to add on the ideas of these solutions. So we have, for non-conductors, we have molecules, and this includes water. A lot of people don't realize, but pure water, if you have distilled water, it does not conduct electricity. Pure water will not conduct an electrical current. If you have a high enough voltage, you can cause electricity to flow through water, but water by itself is an insulator. It does not allow the electrical current to flow. So as much as you might think that water conducts electricity, pure water does not conduct, as well as any other molecule. Alcohols, things like gasoline, all those other substances do not conduct electricity. Okay. We are not going to talk more about superconductors. Sorry, Xander. Tyler, stop talking about benching. Okay. Then the other things that are non-conductors, we talked about ionic compounds in their solid state, and then covalent network solids also. Okay, so all those things are non-conductors. So when we go to strong conductors, right, we've already talked about how metals are strong conductors of electricity. So if you have a metal as a solid or a liquid, it's going to conduct electricity really strongly. We also talked about how if you have an ionic compound as a liquid, it conducts electricity. Because in the liquid state, the ions are able to flow past one another, and because the ions can flow past one another, that allows for the electrical current to flow through. In the solid state, the ions are locked in place, and that's why it doesn't allow electricity to flow in the solid state. But in the liquid state, because they're mobile, it allows the electrical current to flow. Now, the new things that we're going to tack onto this strong conducting list are going to be if we have an ionic compound that is aqueous, AQ, right? AQ. AQ stands for aqueous, right? So it means dissolved in water. So if we take an ionic compound and dissolve it in water, it can conduct electricity. Now, why might an ionic compound, when dissolved in water, conduct electricity? What do we think? What do we think? Why might an ionic compound dissolved in water conduct electricity? So, why might an ionic aqueous be a strong conductor? There we go. Okay, yeah, it's because the ions spread out. It's because we have mobile ions, right? The ions are free to move in aqueous solution. They get surrounded by these water molecules, but they separate. And because they're separated, they're moving around and they can conduct electricity, okay? You can technically only make aqueous solutions with water. Now, there are other substances that you can dissolve things in, but because water is so prevalent, we're going to be talking a lot about water or aqueous solutions. So aqueous ionic are going to be strong conductors because we have mobile ions. For the same reasons, If we have a strong acid as an aqueous, it's going to be a strong conductor as well. Yeah, milk is probably conductive. It's got salt and other things in it that make it conductive. Milk's a heterogeneous mixture, but yeah. All right. Aqueous always means solutions. Yeah, aqueous means it's dissolved in water. Yeah, if you look at your milk, I'm pretty sure, I don't actually know. I need to go, I'll go grab some milk and look at it. We'll get there. We'll get there. Now, all liquids are not conductive if you put something in them. So if you dissolve a molecule into another molecule, it's going to be non-conductive. So for example, if you took alcohol and dissolved it into water, it would be non-conductive. So the solution we talked about yesterday that had methanol dissolved in water, because the methanol doesn't break apart, right, it doesn't conduct. Okay, so yeah, no, it's good, Lauren. It's good to recognize that and learn that. Okay, now our last conductor, the only weak conductors we have are going to be weak acids. Right? So it's only going to be weak acids. So again, the reason why we call them strong acids and weak acids relates back to their ability to conduct electricity. A strong acid is a strong conductor, and a weak acid is a weak conductor. Okay, so we go back to our picture real quick. I'll bring this back up in a second, but if we look at our picture, okay, the weak electrolytes are going to be weak acids, like phosphoric acid, carbonic acid. They're going to be only, or acetic acid, like vinegar. It's going to be a weak conductor. Right? Strong electrolytes, things like strong acids, as well as ionic and all these other things. So yeah, again, Tyler, examples of weak acid: vinegar, citric acid, yeah, and every acid that's not strong. So any acid you can think of or write down that's not strong, lactic acid, right? Those are all going to be weak acids. Okay, good. Let's see, what time is it? 8:53. Trying to think where I want to go. Yeah, let's do this real quick. So let's go to, yeah, let's do this. Oh, sorry. What was Xander's question? Is it possible to have acid in the solid state? Would it still burn and dissolve stuff? Yeah, you can have solid acids. They're usually weak acids, but like, so citric acid is a solid at room temperature. A lot of organic acids, benzoic acid, malonic, no? Not malonic acid, it's liquid. But it's, yeah, citric acid, which if you, so citric acid, right? You know Sour Patch Kids, or any sour candy, the sour powder is citric acid. It's a solid acid, and so when it starts to dissolve, your tongue is like, oh, that's sour. And no, Ellie, the world isn't ending. Okay, all right. I've decided where I want to go with the notes. Let's go to big letter B. So we're going to be done with this idea. We're going to go to big B. So make sure everybody has this idea down. So let's go to big B. Yeah, technically sour powder is burning your mouths, which it's because it's a weak acid. It's usually your bodies can digest it fine. It's not a big deal. Acids aren't near as dangerous as Hollywood would have you believe. They're a huge part of almost everything you eat. Almost all the foods you eat are acidic. They have some sort of acid in them. There's some that are basic, but yeah. Okay, let's talk about, yeah, letter B. So why do substances dissolve? right? Okay. So if I ate a 2-pound, yeah, that would be really bad if you ate a 2-pound bag of Sour Patch Kids in one sitting. It could potentially cause some sores in your mouth. Yeah, and the human stomach is super acidic. It's mostly hydrochloric. Oh, you already did it, Lauren. Nice. You can't burn a hole in a building with acid. It depends on the acid, though. There are some acids. In Breaking Bad, when they dissolve the body, they use hydrofluoric, which dissolves the calcium in the bones. What? No. What? No. Eating an acid and a base is fine. Root beer floats, ice cream, or milk is actually slightly acidic, I think. Root beer floats are totally fine. Salt is not acidic. Salt is neutral. Yeah, so Cooper, that's where we're going next, right? Why do some substances dissolve in some things and other substances don't? Okay, what's the best way to get rid of a body? Oh my gosh, guys, moving on. Okay, so why do substances dissolve? Why do things dissolve in one thing and then don't dissolve in another? Entropy I'll be discussing for my AP class later today. We'll be talking about that at 10. Okay. All right. No, I don't think so, Enya. I think someone's trying to pull your chain on that one. So why do substances dissolve? The idea here is what we're going to use is we're going to use the phrase that like dissolves like. Right. So why does the salt goldfish burn? Salt's just salt. If you have too much salt, your body potentially reacts to it in a certain way. It can start to wear away at some of your tissue and things like that. Okay. Cool. Moving on. Like dissolves like. Okay, so a better way to say like dissolves like is to say that similar intermolecular forces or similar forces right? Similar forces will dissolve in similar forces. Okay, so if you have two substances that can form hydrogen bonds, the likelihood that they'll dissolve in each other is very high. But if you have a substance that's forming metallic bonds and a substance that's forming, covalent bonds, the likelihood that those two will dissolve is very small. So what we can do is we can think about it as kind of like a range. Right, and it goes from ionic to like hydrogen bonds to dipole-dipole to dispersion. Okay. Yeah, Cooper. You can do all kinds of things. Don't worry about covalent network solids, Lauren. Yeah, so there are substances that don't dissolve in water, but yeah, they will dissolve in some other things. So let's focus real quick on this, right? So if we look at another way to kind of write this list would be we could say very polar, so much so that we have individual ions, positive and negative end, and then over here we have very non-polar. So the closer that two substances are to each other, the more likely they are to dissolve in one another. Okay, so with hydrogen bonds, right, we know we've got water here. water forms these strong hydrogen bonds. So water and something like salt are likely to dissolve in each other because they're close, right? So, okay, but water and something like styrofoam, okay, water and styrofoam are very unlikely to dissolve in each other, and you guys know that styrofoam doesn't dissolve in water, okay. So styrofoam doesn't dissolve in water. Okay. Again, they have to be similar but not the same. Yeah. So this whole thing is a range. So as we move, from ionic to hydrogen bonds to dipole-dipole and dispersion, okay, there are some ionic compounds that are so strongly ionic that they won't dissolve in water. Okay. Yeah. So Izzy, acetone. So we know styrofoam does dissolve in acetone. Acetone, if we remember, has dipole-dipole forces. Okay. So styrofoam does dissolve in acetone. Let me pull up a YouTube video of that real quick. Not this one.
9:45, time now to...
Okay, mute this. Right. So let's see if we can get to an actual cool part. Blah, 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 blah. Okay, here we go. So as they add the styrofoam to the acetone, notice, right, it's dissolving, right? It's dissolving really rapidly, okay? So nail polish remover is mostly acetone, right? So you'll notice as they add this styrofoam to this acetone, it's like, well, eating it super fast. Okay, and it's just dissolving, and they just keep adding more and more and more. Okay, so yeah, if we look back to our chart of intermolecular forces, okay, we'd see that acetone and styrofoam are close enough that they'll dissolve. Okay, so yeah, nail polish and acetone are the same thing. It means that styrofoam would dissolve in nail polish remover. Oh, no, never mind. No, you're right, Izzy. Sorry, I misread your question. Yes, nail polish and acetone are going to be very similar. Nail polish, I'm pretty sure, is going to be just dispersion forces or nonpolar. Yeah, styrofoam's mostly air, Cooper. That's why it dissolves so rapidly. Okay, so I want to recap. Let me emphasize this point real quick. Okay, so salt dissolves in water, but salt doesn't dissolve in acetone, right? Salt and water will mix. Water and acetone actually mix, okay? Water and styrofoam won't mix. Styrofoam does not dissolve in water, right? But styrofoam does dissolve in acetone. So the idea is that the more similar our forces are, the more likely they are to dissolve in each other. I'm speaking in generalities, right? There's going to be exceptions to the list. There's going to be things that work. So acetone and water do mix in each other, okay? So if you remember, acetone has the chemical structure C double bond O, C, C, H, 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 H. Right, so that's our Lewis structure for acetone. AP is going to be at 10 o'clock, so in another hour. So when you take off nail polish, it's dissolving. Yeah, the nail polish is dissolving into the acetone. Okay. Okay, cool. I think that's as much as I wanted to say. I don't think this guy is actually in my course, Ellie. I think he's or he or she is just finding my stream and joining, but who knows. Okay. All right. So again, this is kind of all I want to talk about for the notes for today, is just making sure that we understand why things dissolve. So we had our conductivity that we talked about, and we talked about why things dissolved. So let's recap. Okay. So electrical conductivity, we have non-conductors, strong conductors, and weak conductors. Non-conductors include molecules, ionic solids, and covalent network solids. Strong conductors include metals as solids or liquids, ionic as liquid, aqueous ionic, and strong acids. The only weak conductors we have are going to be weak acids. The way you tell if something is a strong acid or a weak acid is by how, basically the 7 strong acids. Okay. When we talk about why substances dissolve, we have this idea of like dissolves like. Similar forces dissolve in similar forces. It is a range. Okay. Thanks, Lollian. That's I appreciate it. I appreciate the compliment. Ainsley, the difference between aqueous and liquid. Liquid just means it's in the liquid state. It's a pure substance like water. Okay. Notes are done, but I'm going to do one more thing in a second here. That's why this says, notice this says notes and practice. We got to do the practice part. Okay. So aqueous is when you have a substance dissolved in water, whereas liquid is when you just have a liquid substance. So like a pure substance that's in the liquid state. So yeah, when we talk about aqueous, it's the solute that we would consider to be aqueous. Okay. Okay, so let's pull up your assignment sheets again. So reminder, you should be doing this reading. The Canvas you can kind of start, but I would wait until we do the notes tomorrow to dive into the Canvas. We need to do some more notes tomorrow before you jump into the Canvas, okay? But we can do Roman numeral 11 now, and 12 actually. Okay, so let's talk about what you're going to be expected to do on Roman numerals 11 and 12. So Roman numeral 11 has the instructions that you're supposed to complete the following equations as why do I have the twice? Typo. Complete the following equations as the chemicals dissolve, right? And so what you're going to do is you're going to say, okay, what happens when all of these compounds dissolve in water? So if it's ionic, or if it's a strong acid, it's going to separate. If it's a molecule or a weak acid, it's going to stay together. So this first compound, sodium nitrate, sodium nitrate has a metal, sodium, and a polyatomic ion, nonmetal, nitrate. And so because we have a metal and a nonmetal, that makes it ionic. So when it dissolves, okay, it would dissolve, so we're going to draw an arrow to say, okay, what happens when this dissolves? So you're going to draw an arrow, and you're going to say it's going to form, caps. Okay, so when it's dissolving, it's going to form sodium ions, aqueous, and nitrate ions, aqueous. If you want to draw it on your paper, right, so how this would appear is we would have this sodium nitrate, solid. So as it dissolves, it breaks apart to form sodium ions, Na+, aqueous, and nitrate ions, NO3-, aqueous. Okay. Yeah. So we're assuming what happens when all of these dissolve in water. So, Lauren, all of these substances we're assuming dissolve in water. Yeah. I'll do another one, Ainsley. Don't worry. So we're assuming that all of these actually dissolve in water, and we're writing what happens when it dissolves in water. I'm going to do more. Don't worry. Okay. So let's look at number 2. Okay, so number 2, okay, nitrogen and oxygen. If we look at, a periodic table, okay, like ptable.com, okay, nitrogen and oxygen, okay, are both nonmetals. They're above the staircase. So because they're both nonmetals, that means this is a molecule. And so because it is a molecule, we know that molecules, we know that molecules do not split when they dissolve. So this NO gas is just going to turn into NO aqueous. Yeah, Caden, I just uploaded the assignment sheet to Canvas so that if you want to print it, you're more than welcome to download it and print it. It's in the modules. So I just uploaded that. So again, because NO is a molecule, it would stay together. Okay. Now I want to actually, so they're all going to be aqueous, Tyler. In the end, they're all going to be aqueous. What you're really deciding here is you're really deciding, okay, does it split into ions or does it stay together? You don't have to. You don't have to write metal, metal, non-metal, metal. Yeah. Okay, so strength of bonds need to be done by today, Tiara. Try to get that done by tonight, by the morning. Molecules don't split ever unless they're strong acids. Strong acids are technically molecules. What I'm going to do, okay, guys, chill out. I'm going to do actually, I'm just going to do 4 and 6 as more examples, okay? So, and yeah, this is going to be due next week. So you've got some time to do this. So probably we're going to say try to have it done by Monday. Okay. So 3 is also just a molecule, carbon, hydrogen, and oxygen. It's not an acid. And so it's just going to stay together as well. I'm not going to do that one. Okay. But let's look at number 4. I want to focus on number 4. So if we have HClO as a gas, okay, what kind of compound is HClO? It's an acid. Yeah, Cooper, right. It's an acid. Now, is it a strong acid or a weak acid? 2 nonmetals is a molecule, Lauren. Yes. So is HClO, is it a strong acid or a weak acid? Ooh, careful, Meredith. So HClO is a little tricky because HClO3 and HClO4 are both strong. But HClO is going to be weak. And because it's weak, what should I write over here? Yeah, you just rewrite it. HClO, aqueous. Because it's a weak acid, when it dissolves, it just stays together. Okay. Now, if we had a strong acid, like, I don't know, number 7, right, it would split apart into H plus and I minus. Okay, so I want to do number 6 as kind of the last one here. So let's, oops, what the heck? Oh, I looked at, okay. So number 6, okay, last one I want to do for this bunch. So if we look at number 6 is FeCl3. Oops. Oh my gosh, I can't write. Again, this is going to be due, we're going to say this is going to be due Monday. It's going to be due Monday. And I'm going to figure out how we're going to grade that and all the way around. Cooper, it doesn't matter. H plus I minus H plus. It's just like in math. 3 plus 4 is the same as 4 plus 3. So yeah, technically a small amount of the weak acid does break apart, but we haven't talked about equilibrium yet. So we're gonna wait. That's more a later idea, Lolly, and you're in AP, so you know a little bit more about this. Okay, so let's focus on the FeCl3. So with FeCl3, first off, what kind of compound is it? So Cooper says ionic. Okay, but answer this question real quick. I think that's Hunter Doyle. Hunter's question. It is strong or weak. There are 7 strong acids. If it's one of the 7, it's strong. If it's not one of the 7, it's weak. Okay, good. Everybody's chiming in ionic. Good. Okay, so if it's ionic, it's going to split apart. Okay, so it's going to split apart into iron and chloride, but we got to be careful when we break it apart. So as we break it apart, it's going to break up into iron and chlorine. Now, iron on the periodic table is not, it's in the middle, right? It doesn't have a set charge. Right? And because it doesn't have a set charge, we have to figure out what its charge is. So for some of you, this is a recap from previously. Okay, so iron, right? If we look at iron, in this compound, what is iron's charge? Okay, good, and yeah, it's +3, right? The way we know it's +3 is because the chloride ion, okay, is one of our halogens, and it's going to form a -1 charge. And so because the chlorine is -1 and there's 3 of them, that makes the iron have to be +3. Okay, and so the iron is going to be a +3. Okay, and so we're going to write iron as a 3+. And so when this breaks apart, it's going to form iron 3+ aqueous. Okay, and then this is really tricky, right? We don't want to write Cl3 3-. Right, that's wrong. That's not what actually happens. Right? The individual chlorines are going to separate out. They're individual elements. And so the way we write that is we're going to say that there are 3 Cl-. So the subscript, oh no, Tyler, +3, 3+, same thing. Totally fine. Technically 3+ is the slightly better way to say it, but that's okay. So again, Hunter, all of these are turning aqueous. We're assuming that they're all dissolving. And yeah, you look at the charge from the periodic table or for the polyatomic ions you have memorized. Okay, so this Fe3+ is going to split into Fe and 3 Cl-. So the 3 chlorines are separated. Yeah, that's a great way to think about it. And yeah, the 3 chlorines are going to break apart. They're not going to stay together because they're not a polyatomic ion, right? There will be. Okay, good. Let's jump down. I guess I said I was going to do this last one, but I want to do kind of one more. Let's look at number 8. So number 8 has this MnIO3 5. So Xander, careful on number 9. Number 9 is a molecule, and so number 9 should stay together. Oh, so Cooper, okay. So remember, the iron here has lost its electrons. It's formed an iron ion. It's not metallic iron anymore, just like the salt, the sodium in sodium chloride is not metallic sodium, it's sodium ions. Same thing here, this iron is not metallic iron, it's iron ions. And so because it has a charge, that's why it can dissolve into solution. Okay, so how would, I want you guys to go ahead and see if you can do this one. How would MnIO3 5 split? What do we think? What's it going to be? On number 2, we did put aqueous. It says aqueous right there. Hunter. Okay, so again, you guys are, I'm trying to get you to predict what happens on number 8. Okay, almost, Lalian. We do need 5 of the iodates. That's a good call. But don't forget, iodate, polyatomic ion, it has a 1 negative. Okay, so this is where we've got to keep our polyatomic ions memorized. So those of you that haven't had a half of chemistry since November, you're going to have to pull out those flashcards and you're going to have to rememorize your polyatomic ions. Okay, so this is kind of a, work our way slowly into remembering the polyatomic ions. You're going to have to go back and rememorize them. Yeah, I know. I'm sorry, Xander. Okay, so good, Hannah. The manganese does have a charge of 5+. Okay. The reason the manganese is a 5+ is because iodate, the polyatomic ion, is IO3-. So it's going to split into manganese and iodate. So the manganese, right, it's going to be a 5+ aqueous. And the iodate, right, there are going to be 5 IO3- aqueous. So you'll notice your polyatomic ions, this O3 stays together. So the iodate stays as iodate, but because there's 5 of them in the formula, the 5 comes in front to say, all right, when we split this apart, it breaks down into 1 manganese 5+ ion and 5 iodate ions, 5 IO3-. Yeah, digital high five if you got it right. Okay, so again, this is the answer. So what I want you guys to do, if you want to, right, if you've done the reading already on, if you've done the reading already on the assignment sheet, right, this Roman numeral 8, go ahead and see if you can work through this Roman numeral 11. See if you can show how they're breaking apart. Yeah, you're breaking apart, balancing the charges. Oh, hydrogen peroxide is not an acid. Hydrogen peroxide is a molecule. Lauren, question, sorry. I'm waiting. I'll put it back up. Okay, if you're super lost, Ellie, remember at noon, at 12 o'clock, I will be in the Discord, and you can join in there, and you can ask questions, and I can share a screen with you, and I can walk you through it. I can give you some more one-on-one help. So Ellie, again, the best thing you can do is join in the Discord at noon, right? Anywhere between noon and 2, and I'll be able to answer your questions there. Okay. Ammonia is not a weak acid, Ainsley. Ammonia is a molecule. If it was going to be an acid, so for our class, for our purposes, if I want it to be an acid, I'm always going to put the hydrogen in front. So the hydrogen will always be in front. So if we look just over this worksheet real quick, okay, acid, not an acid. Acid starts with hydrogen. Acid, 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 acid. So yeah, Hannah, for number 9, it would just be NH3 aqueous. Oh, gases dissolve in liquids all the time, Lauren. Right? How else would your fish breathe? Oxygen's dissolved in the water, right? So that's what a fish gills, the way that a fish's gills work, is it filters through the water and it pulls the oxygen, the dissolved oxygen, out of the water, okay? So gases dissolve in liquid all the time. We'll talk about that a little bit more tomorrow as well. Okay, I've still got a little bit of time. I want to talk about Roman numeral 12 real quick. So Roman numeral 12 says to circle the electrical conductivity. W means it conducts weakly, S means it conducts strongly, and N means that it conducts, what the frick? I'll allow frick. Okay, so again, these are going to be, Naomi, this is all going to be next week. So tomorrow I'll answer a few more questions, and I'll give kind of a firm deadline on when I'm going to have this due later. So don't stress on it now. Just try to keep catching up. Okay, so let's talk about Roman numeral 12. So on number 12, you'll notice, let me pull this up so you can actually see it. Okay, on Roman numeral 12, okay, you're circling, is it going to be a weak conductor? Is it going to be a strong conductor? Or is it going to be a non-conductor? You can't say thought. Okay. So weak conductor, strong conductor, non-conductor. Okay, so what you're doing is you're going to use the list we made. Right? Your list we made of what we said were non-conductors, strong conductors, and weak conductors. And you're going to assign based on what we have on Roman numeral 12. So the first thing we look at, we say barium hydroxide. Okay, what kind of compound is barium hydroxide? Right? Barium is a metal. Hydroxide is a nonmetal, right? So we have a metal and a nonmetal. That means that this compound is ionic. Aqueous ionic, right? Let's see, aqueous ionic is a strong conductor. Okay, so because aqueous ionic is a strong conductor, we would pick strong. Right? And so that's all you do for this. Okay, so oh my gosh, you guys are freaking out. Isaac, why'd you have to distract my chat? Okay, so work on this. We'll do it all later. If you have more questions on it, you can, of course, hop into the Discord at noon. I'll be answering questions from noon to 2. And then we'll talk more about this tomorrow. Any other final questions before we end the stream and the lesson for today? I'm not hosting you, Caden. The Discord link is right under my Twitch chat, so you can just look under the screen and you can check the. You can just link straight to the Discord. I've got to get ready for my AP lesson. Sorry, Zach. Just at noon, just hop into the Discord and I'll be able to answer it then. But I've got to prep for AP in the next half hour. Okay, otherwise, right, things that you need to get done. If you haven't graded and recorded the Strength of Bonds worksheet on Canvas, you need to do that. That's your top priority. Grade and record the Strength of Bonds worksheet. If you haven't read these pages from your textbook, read those pages from your textbook. If you have graded the Strength of Bonds and read those pages, see if you can work your way through Roman numerals 11 and 12. I'll go over metal, non-metal. I can do all that stuff in Discord. Lauren, I can answer every single one of your questions in Discord later. I promise. Okay. But otherwise, I'm going to go ahead and end the stream for today. I'm going to put it up on YouTube. 11 and 12 are going to be due sometime next week, Xander. Maybe Monday or Tuesday. No, I guess my kids are downstairs. They're not up here, so I can't think. I will, Izzy, I will post reminders on Discord. I'll every day in the stream, I'll remind you about it, homework. I'll put reminders on the, oh my gosh, put reminders on Canvas. I will remind you as much as I can, okay? Yeah, well, I have a lot more people in honors, Isaac. There's 60 people in here. Only 30 in AP, okay? So anyways, you guys have a great day. Hopefully you're keeping caught up in your other classes and your other teachers are doing something. And we'll stick with that. Catch you guys later.